Right, this evening, I'm going to have a look at this TTI function generator. And I bought this at work 15 years ago, 15 maybe 20 years ago. And this function generator display was used to program some of our power supplies to generate sort of dynamic focus amplifier signals and various synchronization signals. I've been using this for the last 15 years on and off, and it's been very reliable. But it slowly became harder and harder to operate the control buttons, the entry buttons. Some of these push buttons wouldn't work. Sometimes they would, sometimes they wouldn't work. Sometimes they, and then you sometimes get a sort of like a switch bounce where you press it twice and you press it on and you turn it off again. It's a bit like the old Texas Instruments calculators used to suffer the same problem. So we put it aside for a while, and then I used another generator, came back and powered it up, and it wouldn't work at all. Unfortunately, the day we were powering it up, it was going for calibration. So we took it to obviously the calibration and said, we don't think it's working properly, just have a look at it. And they said, no, it's no good. You can't get any control over it. So it was scrapped. So, of course, straight away, you know what happens to stuff that gets scrapped from work. It comes back here. So this is, as I say, sort of like a 90s technology function generator. Does lots of sort of sweeps and things like that. It doesn't sweep above 10 megahertz. So that would have been useful for FMIF, but can't have everything. And really, this evening I'm going to try and see if I can work out why it's failed. And I'm suspicious what it is. I don't know if you previous followers remember the Roden-Schwartz problem I had with the sticky keypad. I've got a funny feeling it's probably something to do with that. So let's switch it on, see what it does. And you see it powers up, it's got a nice backlit display. And it comes up with a self-diagnosis check. Basically it's come up okay. If it comes up with that, it's functioning. And then that should clear. And then there's our main display. And these are actually quite nice little generators. TTI stuff is usually fairly budget, but this particular one's pretty well made. They do make some lesser models that are really sort of more or less unusable. They're just very cheap and nasty. This is, as I say, a pretty usable sort of and worthwhile repairing instrument if we can get it fixed. So let me just show you what happens. Press anything here. So I want to enter a frequency, or I want to select from sine wave to pulse wave, for example. No control over the display at all. Whatever I do, nothing happens. So we got a problem here. However, you will notice with the rotary encoder, and I'm just zooming because you won't be able to see that, when I turn the rotary encoder, you see it selects from period to frequency. So it is doing something. So that suggests there's no processor error. There is a problem with one of these switches here. And I think it's exactly the same with the Roden-Schwartz. One of these switches is short, or got a bit, or there's a break in the board maybe, and that's why we've got no control over the front panel. So I'm going to have to take the front off, pull it all apart, and have a look inside, see what type of switches it's got. It's probably these membrane switches, but I can hear them clicking nicely. I'm just hoping it's not these sort of like carbon impregnated ones, because if it is, that's going to be a pain to redo all that again. It might be just the sort of like this little stress ball, sort of like a little plastic film over a little sort of little bladder thing, and they seem to work quite well. They seem to be the later ones they use. But if it is that, whatever we've got to do, we've got to try and work out what's going on and try and repair it. Try and at least find out which switch it is. It might be more than one. It might be one or two. It does look like it has some fluid spilt in it at some point, and I'm just wondering how that's happened. But I can't remember ever spilling anything in it, but it is possible I've cleaned the front panel at some point. And of course that is one no-no with these. If you get one that's mucky, don't spray fluid all over it and wipe it down. If you're going to clean it down, wipe it down with a damp rag with some sort of like, I don't know, some furniture polish or something to remove all the sort of like gungy fingerprint marks. But don't spray directly onto the keyboard, because it'll get into the back of the switches and short everything out. And I'm starting to wonder now if that's possibly what's wrong with this one. Okay, so let's take the top off and have a look inside. Okay, that's inside. Not a lot to it really. So the microprocessor in the middle and a ROM. Power supply, regulation. Looks like some sort of like filtering going on in over here. Lots of ribbon cables and things, relays for probably attenuator. I'm expecting a master oscillator here. There's obviously the master oscillator down here. So easy to work on and not a lot in it. There's actually a memory retention battery at the back here as well. Obviously, because it's not that old, it's in pretty good condition. So let's get the front panel off it and have a look and see what the switches look like. Okay, we've got a new view here, so let me know what you think. So two ribbon cables. One goes to the front display and the microprocessor that does all the display here, as you can see on this little board here. And this ribbon cable here does all the keyboard control and the rotary encoder. Now we know the rotary encoder works, so let's get this board out and have a look, see if we can work out why it's not working. Well, this is the front panel out, and I'm quite impressed actually. These are all individual switches, you see. Nice little individual mounted switches. Much nicer than I was expecting. I thought it was going to be like a membrane keypad. So my opinion of this thing's gone up slightly. Than I thought it was going to be sort of like a real budget build quality, but no, nice switches. So I think we need to have a look through so we can see anything obviously wrong. I did spot this LED. I don't know if you can see this. I don't know if someone's had this apart before to look at it inside here. I don't think it was me. It's been kicking around for a while. That LED was bent over, but I can't see that causing a problem. So I think what we'll do is we're going to, I'm going to power it up, holding it just like this, just to see if that has made any difference. And then I'm just going to go around and measure sort of switch contacts and see if any of them are actually short. It could be just a bit of dirt in one of the switches. It could be the switches are shorted, but let's have a look and see if it's liquid damage. Maybe it is liquid damage. Switches. I didn't want to go through the switches live on air, but just to show you roughly what I was doing, you've got push to make switch, so continuity test. The two centered connections are common and two outer connections are common, so there's a push to make. So if I put it across there and press the switch, it makes contact. Went through them all, got to this one, and it's permanently short. This switch here looks like it might be causing the problem. So are we on to something? So that switch, which is the field to the right switch, looks like it's got a short on it. Let me just check again, just to be sure. Yep, there's definitely a short on there. So I think what we'll probably have to try and do is unsolder the switch, just to make sure there's not a short on the board. No reason why there should be. And then we'll have a look at trying to repair the switch. Right, I went through some surface or contact cleaner. I went through that switch and gave it a couple of taps and sort of like shook it and sort of shook all the excess fluid out. And the short seems to have cleared now. So if that was the problem and there aren't any other shorted switches, I expect this thing to work when I plug it in. So let's try it. Display. Right, will it work? Nope, still nothing. Alright, okay, so there's either another shorted switch or that wasn't the problem, but at the moment, no improvement, as long as I've connected everything back up correctly, which it looks like I have. Yep, okay, so let's turn it over again and try something else. I went through all the switches again. I know we went through on the continuity test, but I thought, well, maybe it's sort of like a leaky, sort of contaminated switch. All these switches measure, when they're connected to the unit, about between 45 and 55k, which is fine, apart from this switch here. And this switch, when I measured it, measures 2.7k. So, next one is suspicious of is this switch. So that switch there, without turning it over and trying to work out which it is the number 7's button, I think. So let me just turn the meter around so you can see. Hopefully you can see. Just zoom out a bit. It's not ideal, I know, but it never is ideal getting a video shot in here. I'll try and show you what's going on. So this is the switch. As you see, it's measuring about, well, it's 3k depending which way I have the lead round. That's one way. I think the other way is 7k. Well, it's 3k now. So let's operate the 7 button, or this button, a couple of times and see what happens. See if it makes any difference. Now this isn't a fix, but we could try some contact cleaner. It's 3.4K. Right, so I'm going to squirt some contact cleaner in that switch and see if we can get anything out of it that runs out. Now it could be contamination with something. It could have been a liquid damage. It's starting to look like liquid damage. There's no impact damage, I can see. Okay, gone up to 61K now. Alright, so I think we're going to power it up again. So let's might as well just do it now. Power it up and see what happens. Make sure everything's plugged in still, which it is. Nope, still nothing. Alright, well, not going to give up yet. It could still be a dodgy switch. It could be something. It could be a broken board. It could be a microprocessor fault. But I'm not giving up yet. Let's move on to the next step and see what we can do with that. Right, I've gone over and cleaned all the switches out again. It seems to be any contamination in these switches will cause a problem. It seems to be even if you've got a couple of meg, it will the unit will think that the switch is being pressed. So I've gone through, cleaned them all out again. I've got them as high. Most of them are showing sort of infinite in resistance now. I've left them to dry for half an hour. So let's power this up again and see if it works now. Moment of truth. Okay, that's working. That switch doesn't seem to be working. Can we adjust the field? Yep, that's working. So let's go back to field. Where are we? Flashing. So we're looking at see where the flashing cursor is. Not easy for you to see. I think I'm going to do is, it looks like it's working. It looks like possibly we haven't got any control over this switch here or this switch here, and they are different functions for this sweep and ramp, triangle and that sort of thing. That switch is working. That one doesn't seem to be working. Not sure why. Everything else seems to be working. So let's let me have a quick look at that. But it's certainly working better than it was earlier on. Okay, I'm just going through to check on the main board, make sure there's nothing wrong there. They've got these little transistors here, surface mount transistors Q11, 12, 13, 14, 15, 16, etc. Q13 looks like it's got a short on it. So I've taken the transistor out and tested it off the board, and sure enough it has, there is a short. It's just a bipolar transistor, a BT539 or something. I'll check the number and let you know. So I've got some of those. I'm going to try and fit another transistor in there. I wonder if I misconnected the inline connector here. This like IDE sort of like a ribbon cable. Maybe misaligned it and blown something up. But let's change that transistor out and see if we get any keyboard response then. Okay, here's this transistor we've got to change. There's a pair of tweezers next to it, so it's a tiny little thing. So we're going to mount this on the board, and hopefully this will solve the problems. Now, I don't know why it's, as I say, I don't know why it's short. It might have been failing. It might be an intermittent transistor, and unlikely. More likely I've reconnected the connector out the wrong way. So I'm pretty sure I haven't. Let's plug that in, and let's see if this fixes the problem. Alright, got that in. Bit of a fiddle, but that's in nicely. Let's power it up, see what it does. Right, let's see if this does anything. Nope. Still nothing. Oh, we've got adjustment there. Still not working properly. Some of the controls work, but no, we've still got half the controls not working. So, alright, let me check the switch contacts again, and then just check the other transistors, I suppose. Well, I think I may have fixed it. I've been through the switches again. Some of them were sort of like a couple of meg, but one of them was like 30k. So reiterate that don't spray anything in front of these, or the front panel of these things. If the contacts get slightly resistive, I think it's going to cause problems with the computer. It thinks that all the buttons are held down. It doesn't know basically can't see the wood from the trees. I think, you know, it thinks that a button's held down and it just holds the processor in a lockdown sort of state. For example, if that button's held down, nothing else will work. Let's power it up. Let's see what happens. It certainly seemed to be. Turn this backlight out a bit so you should see a bit easier. Okay, self-test. So it's still a bit flaky, but it's working. And it's actually it's packed up again. Okay, let me just try flicking this switch. Now I still think there's a dodgy switch somewhere. And it's done the same thing again. That was working briefly. There it is, see? So there's a switch here. If it detects the slightest resistance, it thinks there's a problem, and it's one of those four switches there. That's the up, down, left, right selection buttons. So let's try period. So it should be field. So move to the right. Let's try 1, 2, 3. Enter. Yeah, it's working. Alright, so what I need to do is basically, as I said, make sure these switches are absolutely fine, put it back on the front panel, power it up, see if it actually produces any output. Okay, it's the front panel back on. It's a BC859C transistor I replaced, and it had a collector emitter highly leaky, so basically the transistor was conducting all the time, and that was probably causing half the problem. As I say, I don't know if that's because I put the ribbon cable on the wrong way, or that was just happened to fail, you know, whilst I had it apart. It might have been actually the problem all along. I don't know, but I certainly think that there was fluid in the switches, and causing the thing to sort of short out and make it unresponsive to the front panel. So let's switch it on and have a look, see what we got, and hopefully it will be okay. Now I still suspect there's probably a couple of the switches are going to be a bit intermittent. Once it's dried out, I'm sure it'll be fine. But so let's have a look. So sine, pulse, ramp, that works okay. Square, pulse, negative pulse, triangle, negative ramp, that works okay. So let's try, basically we got a cursor, so moving this flashing cursor along here, move that along to the next. Yep, that's all working. That's working well. Just check all the other buttons work. Yep. Yeah, it all looks like it's working absolutely fine. So next thing I suppose is to connect it up to an oscilloscope and just have a look at the outputs. Now I did disconnect the battery that stores the recalls, and I'm not sure if it's affected the calibration. I don't think it has, but I just need to verify that the calibration is still good. But this looks like a fix to me. Alright, let's see if this thing works then. Connect it up to the oscilloscope at the top. Let's power it up, see if we get anything. Just basically interested in, we sort of like got some sort of output from it. So here we go. It's a set of 10 kilohertz with a voltage of 20 volts peak to peak into 50 ohms. I'm not terminated with the scope, by the way. Symmetry of 50%. So if I press output, we should get something on the scope. There we go. We have got something on the scope. Okay, that's good. So we can try a positive pulse. Yep. Bring it up a little bit so you can see. It's difficult getting all this in frame at the same time. Positive ramp. Yep, you can clearly see a ramp there. A square wave. A negative pulse that goes below ground. A triangle. And a negative ramp which goes... Was that a negative ramp? Yeah, it's a negative ramp that goes below ground. So the ground potential starts here at the top of the waveform. All appears to be working okay. Let's just try our frequency adjustment. So let's go digit, and this should adjust our frequency, and it does. It's working well. Try to find the frequency adjustment. Holding this on the scope, let's ramp that up a bit. There we go. So that's working fine. I assume everything else is working. Let's try DC offset. I'm not sure if the scope's DC coupled. I can't see because I've got the... I think we're AC coupled on the scope at the moment. There we are, DC coupled, so we should see something. We've got the alarm going off saying that there's a possibility of clipping. Interesting, it doesn't seem to be adjusting the offset. It's probably because I've got the level up so high. Hold on a minute, let's just try this then. So amplitude, let's make it 1 volt. So we'll 1 volt, where are we? Volt, there we go. Turn the scale division down. Got a triggering back again. Now if I adjust the amplitude, the DC offset, you should be more noticeable. So where are we? DC offset, let's adjust it now. There we go. Yeah, just because we had such a high signal. So the DC offset's working correctly as well. Basically looks like it's working perfectly okay. Well, at the moment, perfectly okay. I think the buttons, as I say, need drying out. Possibly with I'll probably just get a compressed air line and then blow them in the front panel. And just blow out, you know, get some compressed air and then dry them all out. Maybe even leave it out in the sun for a bit to dry it out. But most of the buttons seem to be working fine now. So I'm quite happy with that. So it's a working TTI TG1010A. Doesn't look like it needs calibration. It hasn't come up with any calibration errors. Thanks for watching. More to come.